Chemical periodicity. Chemical periodicity refers to the arrangement of elements in a structured format that we call the periodic table, and how the properties of the elements relate to that arrangement. The first chemist to really explore the concept of chemical periodicity was a 19th century Russian chemist by the name of Dmitry Mendeleev. He arranged the elements by increasing atomic mass and found what we call now periodic law. Periodic law says that if you rearrange or arrange the elements in order of increasing atomic mass, or in modern terminology, increasing atomic number, we find that certain chemical properties will reoccur periodically throughout this sequence. Mendeleev used his model that he created to predict the existence of an element called ecosilicon. At the time that he constructed his crude table, there were only about 65 of the current 118 elements that were known and observed. And there was a hole that existed in the periodic table where germanium now sits. And he predicted, because this is right below silicon, some specific properties that this element should have if it existed. A while later, there was a German chemist who discovered the actual existence of this element and found that its properties matched those that Mendeleev had predicted. So this supported the model of chemical periodicity that Mendeleev had set forward. The element was named germanium after the country of Germany, which this chemist was from. Now, in modern terminology, because we have mass overlap in a lot of our elements, particularly the higher level, or higher atomic number elements, we use the atomic number rather than the mass number in order to rank things in the periodic table. So we're ranking by number of protons rather than by overall mass in modern periodic tables. The periodic table is a means by which we categorize things now in modern chemistry, and it arranges all of the elements by increasing atomic number. In the periodic table, there are two different components. There are columns and rows. Columns are called groups or families. Rows are called periods. This is where we get the term periodic table from. The elements in a group have similar properties. So all of the elements in the first group, like hydrogen, sodium, lithium, all have similar properties to each other. In classification, there are two ways that we can classify the periodic table. We can classify it by its makeup, whether the elements are considered metals, metalloids, or nonmetals, and we can classify by what we call main group elements versus transition elements. Metals are on the left-hand side of the periodic table and tend to be further down and to the left, and in terms of increasing metallic character. So those elements which are furthest to the bottom and left of the table are the most metallic. Those which are to the top and right of the table are the least metallic. The properties of metals are that they are solids at room temperature with the exception of mercury. They tend to be shiny and malleable, which means that they can be bent or hammered out into sheets. They tend to be ductile, which means that they can be drawn out into thin wires, which is what makes things like copper so good for transmission of electrical signals through conductance through a long wire that can be drawn out. And they are good heat and electrical conductors. In terms of chemical reactivity, metals will tend to give up their electrons and form cations in chemical reactions. If we look at the periodic table, then metals are all of the elements which are outlined in red here. Nonmetals are on the right-hand side of the periodic table, with the exception of hydrogen. They tend to be less metallic the further up and to the right one goes in the table. And metals tend to have varied states at room temperature. They range from solids to gases depending on the particular nonmetal. The solid nonmetals are often brittle. They break apart. They are poor heat and electrical conductors. What they're actually called is insulators. And they tend to take electrons and form anions in reaction. So we see here the nonmetals are represented by the blue outline. Metalloids are in between the border of the metal and nonmetal sections. Their classification is widely disputed in the chemistry community. A lot of people feel that the metalloid category shouldn't exist because most of what are considered metalloids are more or less either metal or nonmetal in their characteristics. Silicon is the only one which is a very good example of a metalloid. Metalloid properties are that they are solids at room temperature and have a mixture of properties. They tend to be semiconductive, which means that they can have alternation in their conductive property. Their intermediate ability to conduct heat and electricity makes them very good for things like computer chips, and we're doing gated voltages and things like that in a computer, because we can control the conductivity of the silicon. Metalloids you see here are represented by the green elements, and they follow this purple stair step down the periodic table.